I've had a question about how to create a box and whisker plot, and more specifically about how to find the interquartile range. And so, what I thought I would do is to look at this problem and see how to make a box and whisker and how to find all the information that is associated with it. As you can see by the question, it says, "This basketball season, Mike scored the points as illustrated in the stem and leaf plot shown below." So the first thing we need to remember is how to actually read this stem and leaf plot. We see that we have a stem that goes with the leaf. So how we read this, in other words, is Mike scored 10 points in one game, and I get that from the 1 and the 0 here. And then in another game, he scored 11 points, and in another game, he scored 11 points, and then he scored 12 and 13. And then I see that he also scored 20 points in a game, 21, 21, 25, 26, 28. So I want to go ahead and record all of those. 20, 21, 21, 25, 26, and 28. And then we see that he scored 31, 32, and 33. And 40 and 41. Now, a box and whisker is also known as a 5-number summary, and so the 5 numbers that we use are key to answering questions like something as simple as what is the interquartile range. So the obvious ones, or the easiest numbers that we can use, are the lowest number and the highest number. The lowest number in a box and whisker plot is called the lower extreme. And the highest number, or the largest number, is the upper extreme. Now, box and whisker plots are also known as 5-number summaries, and so here is where I get 2 of my 5 numbers. Now, the other 3 numbers come from dividing this information in half and using half of the information. So what I need to do next is to go ahead and calculate. Well, not calculate, but let's just find the median, or where half of the data, where we would have half the numbers on one side and half the numbers on the other. So in this set, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. We have 16 scores. In other words, there were 16 games. So that means I would have 1, 2, 3, 4, 5, 6, 7, 8. I have half of the games here, and I have half of the games, I have half of the games to this side. So here is half of my information, and here is the other half of my information. 1, 2, 3, 4, 5, 6, 7, 8, and then 1, 2, 3, 4, 5, 6, 7, 8. Now, we need to find what the median is, and if you notice, we actually have 2 numbers that are in the middle. We don't have one number that separates it because we have an even set of data. So we have 2 numbers that are what we would try to find. We need to try to find the median of these 2 things. So where is the mean of these 2 things? So where is the median? What is half of the data, or where is half of the data? To find that, we would say 21 plus 25 to get 46, and then half of 46 is 23. So our median number is 23. That represents, where the middle would be of this data. Okay, so here's 1, 2, 3 of our numbers of our 5-number summary. So the next thing we need to do is to take half of the data, in this case 10 through 21, and let's find the middle of that again. That will give us another one of our numbers for our 5-number summary. So 1, 2, 3, 4, 1, 2, 3, 4. So somewhere between 12 and 13, where I would have, once again, half the numbers on this side, half of the numbers on this side, and that would be 12.5. If I add up 12 plus 13, I get 25. Divide that by 2 to get 12 and a half. And then on this side here we have the other half, the high half of the data, 1, 2, 3, 4, between 31 and 32. I would have half my data, and between 31 and 32 is 31.5. So the next thing we need to do is we have our 5 numbers. So what we want to do is plot these numbers on a number line. So notice I have a number line drawn up. Now the next thing we want to do is to label this number line so we can plot our points. All right, so I'm just going to start on this end. I'll just start with 10, and each of these tick marks I'm just going to use. I'm going to go up by 3s. All right, so I have my number line labeled. And so next thing I want to do is I want to plot all of my numbers. We have the lower extreme, which is the lowest number, and we have the upper extreme, which is the highest number. And that was the easiest. Let's just start right there. So the upper extreme, I'm going to put a dot where that is, or the lower extreme, I'm sorry. The lower extreme is 10, so I'm going to put a dot above the 10. My upper extreme is 41. Now notice I don't have a 41, so I'll just go somewhere between 39 and something really, really close to 42. So this is 10 because this is my lower extreme. This is 41. This is my upper extreme. The median. We found the median just a second ago. This is the median for all the data, which is 23. So I'm just going to put a straight line where the median would be. And this number, 12.5, somewhere right in this area, that's 12.5, and then 31.5 somewhere in this area. Now, these two places have a name. These are specific locations, and this 12 and a half that we found earlier, this is my first, or it's the lower quartile. And this 31 and a half, it's the second, or it's the upper quartile. Now, I'm using the word quartiles because, as you can see, if we were to look at these numbers from 10 to 12 and a half, that is 1/4 of the data. And then from 12 and a half to 23, that's 1/4 of the data. And then from 23 to 31 and a half, that is 1/4 of the data from here to here. And then finally from here to the upper extreme is 1/4 of the data. So this is my first quartile. This is 12 and a half, and this is my third quartile, this 31 and a half, and I use that to make, oh goodness, if I just draw two lines that connect them, you see that we have what we would call a box and whisker. Now, a box and whisker, this is a picture of the stem and leaf, and what this is, it shows how data is distributed. And we can see from the lower quartile here at 10 to the first quartile, that's 1/4 of the data. And from here to here, that's 1/4 of the data. And from here to here is 1/4. And from here to here is 1/4. So all of this represents all of the data. Now, the question I have below is, what is the interquartile range? range? Well, to discover my interquartile range, I have to take the upper or the third quartile minus the lower or the first quartile. So to discover or to calculate the interquartile range, I would take 31.5 minus 12.5. 31.5 is my upper or my third quartile minus my lower or the first quartile. Subtract those two to find out the inner quartile range is going to be 19. In this case, 19 points. So in order to find the interquartile range, use the third quartile minus the first quartile. I hope this helps, and I continue to plan on posting some new videos. Please let me know if this helps things, or hopefully it doesn't make it any worse. Thank you.